Adra, you there? Do we have Adra? Take support. Let me check. And let's begin the next version, or let's say next module of convolution neural network. That is part two. I hope everybody is aware of CNNs, right? How CNN works. So today we're gonna understand some more concepts like how do we, leverage transfer learning. So we'll be having a pre-trained model, and we'll be implementing the same for, let's say, any kind of random images which we are going to get. Residual connections we are going to build up. So ResNet will be used here to skip connections and resolve vanishing gradient problems. So ResNet, VGG16, YOLO, all these are the new instruments which we'll be using as a platform will be using to build up the model. And not only build up the model, actually, it is just transferring the learning, what we get from the existing models. So these are already built up models by different teammates, and they have their own infrastructure. So let me again talk about ResNet and VGG16. So these are common, let's say, architectures in handling images, and that I have already given you with respect to the common 10 variants. Oh, this is great and decent. 10 variants of what happened to this?
Ravi, did we completed the CN part one?
Sorry,
Did we completed CNN part one?
I believe so, right? I mean, we had discussed the part one was nothing else, but that was the previous exemplary. Let me tell you. Just wait. Let me first of all discuss part one. What was that? And then I'll again share my screen. Just a second. Let me pull the material. Right. Again, want to have that, or maybe we need to discuss again. I think we have discussed, right, the convolution layers, pooling, fully connected activation functions. Can somebody confirm? If not, then I can take it. No worries. Because last week was holiday, right?
Yeah, last week was holiday.
Okay. Let's begin then part one. Let me check the part. This week, which week? 28 or 29? What is that week number?
It's a week 28 only, right?
28 only. Okay. So this was the last then, right? Can you confirm? Okay. There also we built up a CNN, but that was for Cipher 10 datasets, right? There we are at dropout and batch now. Is it the same which we closed?
Yeah,
Drop.
that's
Okay.
what my understanding, sir.
Perfect. No worries. Let me then handle the part one accordingly. Let's do that. And part one is almost same like we already have discussed. CNN, what else we are doing? Let's see. We are doing some processing here. That's on the image augmentation part. So regrets for the inconvenience cost. We are going to discuss image data augmentation and boosting computer vision with artificial diversity. So data augmentation means generating the data. And how we are generating, again, AI is being utilized there. And we'll be using computer vision for sure. Now the problem statement is that when we are dealing with convolution neural networks, they have large labeled data sets, right? And large labeled data sets means high dimensions. When we say high dimensions means overfitting. So CNNs basically are the best possible algorithms so far available for handling images. But the only problem is that when we have huge dimensions which are there, that accuracy would be higher and overfitting issues could be there. So therefore, to prevent that, what we can do is we can have a supervised data. This supervised data will be a labeled data sets, especially if I have certain images. Let's say I want to identify certain material, right? For example, there is a truck which carries raw materials and whatever the spare parts and all. We need to check what is the level of this truck, and without actually weighing the particular, any container. So we need to see that if this particular raw materials are there and they are especially the liquid, right? They are packed in containers. What exactly we can see is if this is something like a raw material, which is a kind of a raw material for, let's say, copper utensils or anything. So the copper is there. The truck is carrying a copper. And what happens is we need to implement a computer vision solution on the gates, wherein we can see is there any kind of a pilferage happening or any kind of stealing happening when the copper is being transferred from one place to another. Maybe it could be factory one to factory two. And on the gates we need to have a check. Via transit we need to have a check. And there is no other solution than to implement a scanner with a computer vision, that is a kind of a CCTV cameras can be installed, a particular GPS can be installed, and they can work in hand in hand together. So when I say this problem statement is coming in, this coming in from various companies, big companies which they are implementing these kind of solutions. Even they want to weigh the containers also, like what is the weight of the copper inside that truck, just by physical inspection. So there are multiple ways. Instead of sensors, they are also having physical inspections these days. Computer vision is again working out on that. There was one common use case which I used to work out long time back, where the pH of or the acidity of the milk was to be predicted, and so that we can understand the condition and the health of milk. And the client actually mentioned that whenever the cows or the kind of buffaloes, they are having agitations or they are having altercations amongst each other or fighting, right? What happens is they get agitated, and the milk which they are going to give after a few hours or few minutes, it's also getting some let's say impact. I mean, I was surprised like this kind of a conditioning is there. So what we did is we installed computer vision based solutioning, so that we can get the alerts whenever there is a kind of a altercation happening or agitations happening amongst the herds of cows and buffaloes. They can be alarmed. At the same time, they can reach there so that the conditioning of the pH values of the milk doesn't go that high. Because what happens is the moment it is high pH milk goes to the factory for further processing, the shelf life of that milk is very less, and therefore they had to implement all those kind of things. Though there are refrigerants, everything is there, but yeah, the pH should not be high. Crazy. So this kind of solutions are already there in the market. And what is the common thing there? They are using computer vision, and especially CNNs are also helping us to work out on the images and videos and everything. So if it's a video, it is nothing else but frame per second, which I can get through using OpenCV. And that OpenCV or Open Computer Vision kind of library can help us to work out on all those problem statements. So the problem is that the CNNs need large data sets, labeled data sets. We need to, uh, if it's something unsupervised, for example, I have not yet seen a particular object and the camera is there, the camera is trained upon large number of similar objects, which could be from the existing repository, public repository you can take, but it can alter on the shape, size, color, whatever on a number of grounds if it's something which is highly random environment. So depending on use case to use case, CNNs are requiring multiple such kind of physical efforts, manual efforts in terms of labeling those images. That's the major problem in the industry. What has happened is with the advent of generative AI, images are generated today. I mean, the topic which we are discussing is augmentation, right? These augmentations earlier were done with GANs kind of a environment where we have autoencoders and we have generative adversarial neural networks. All such kind of mechanisms were there. Autoencoders basically were used to create fake images and using the existing image. For example, there is a volcano. We need to showcase that how the volcano would look like when it's getting erupted. So autoencoders kind of unsupervised models were used in neural networks. But today, because generative AI is there, we can create images from prompts. So you don't feel any problem there. So data augmentation is not a problem today. Earlier it was like that. I hope you got the crux. When we say data augmentation, it is just to get more clarity, more supervised information to the model, so model can understand that image in a better way. Something has not happened, but we can have some kind of unrealistic images or augmented images which can be further utilized. Sometimes noise is to be created in the data so that we can avoid a certain underfitting or overfitting issues. So that also can be done. Any questions before you go ahead? Hey, am I audible? Team?
Yes.
Any questions? Any questions on current practices versus old practices or anything? So then I can discuss that concept as well during the session. So the main problem is how come AI agent will learn unless it has the understanding what is to be learned upon. But for me today, this is nowhere a problem statement because with AI itself, with OpenAI models, with Gemini models, right? With any LLM engine which is having multimodality, I don't find any problem with respect to shape, size, color, any object. Even if you want to create an object which is highly cellular in nature, for example, human body cell, we have to create. Today, I can write a prompt and can create it. If I'm talking about generative design, right? Factories having cars and all those things, they need to try simulations on design part. Today, I can write a prompt and get integrate that with a work fusion kind of a software, AutoCAD kind of a software where we can do all this kind of design principles easily. So though we are discussing just to understand how it has been handled in the past, but today data augmentation is not a big challenge. What's your point of view? Anybody? Data augmentation from fake image generation perspective. But if you say quality of a data augmentation, I mean data augmentation from quality perspective, like blurring an image or processing its, let's say, pixels, that we can definitely do. But for me, multi-models are there, which can handle computer vision in most efficient ways, as per my understanding and practices. Anybody would like to add or delete something from the point of view, or I can go ahead further. Right. So the challenge is collecting and labeling data, but I can use an agent which can collect and label the data accordingly. So not much problem. And this was a major task, labeling task, not only for images data, vision data, but also for text data. But we have labeling services these days, right? I don't know how many of you are aware. Let me show you some existing labeling services as well, apart from agents, what we used to have. So you can see that there is a marketplace at AWS and at Azure also you'll find those marketplaces, right? So there are label inspectors, there are generative AI lab with human in the loop annotation, right? For tuning, testing, etc. So let me show you one labeling service here. If you can see, we have model hub integrations, project management, role-based access, healthcare resources, blah, 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 visual document understandings. So we have for images, for documents, everywhere, we can work out on all this kind of, labeling services. Somehow they have 500,000 kind of employees working only, I mean, from Azure, AWS itself. They have a task force of 500,000 people, and their task is just to label the solution. And that's, I think, $1,000 a month. So most of the big industries, they wanted to work out on this kind of things, right? So they can directly leverage cloud services for labeling tasks if they don't have it. Otherwise, interns are there today to deal with these kind of labeling jobs. You can get the interns hired and can get them trained, and there are labeling tools as well. So there are automated labeling and annotation tools within each cloud. So let me show you one more thing, that is Azure data labeling tool. All right. So if you want to have image data labeling workarounds, right? Azure Machine Learning has text data labeling, image data labeling, all those kind of projects, right? So you can directly use those particular things in Studio.
Or Ravi, just we need to feed the source raw data that will
Yeah.
be the output of the labeled data. That's it. That's the thing, right?
Yeah. So there are two things. One, if agent is there, it will do automatically. But if human in the loop is required, we can also have that. So prices are like, there is a very small delta there. Agents being utilized doesn't require human in the loop with, let's say, that number. So slightly at a lower side. But if human in the loop is there, there is 100,000, sorry, $1,000 kind of a charge for some number of images. But yeah, directly
Okay.
pull the raw data, you will get them labeled. That's it. It
So
is absolutely.
human in the loop in the sense, let's say the machine does all or what permutation or combination of sampling is required.
Yeah.
Because if I have to do verify everything in manual, again, it's a
No,
unnecessary
no,
level.
it's just testing. So it's an audit by human in the loop. So maybe they will select randomly the images and all. They'll just take less time than us. They have their own quality check mechanisms. Maybe they are using a software to update all those things, results. So that's why.
Okay, just a simple feedback of right or wrong. I mean, like the thumb,
Yeah, correct.
that's sufficient. Okay, okay, got it.
So today these problems are not there. I mean, with cloud practices. But earlier it was very hectic. I mean, I used to see that we used to hire interns and we tend to, work out with them all together. Uh, did I close that? Okay. Sorry. Yeah. So gone are the days. I mean, multimodalities. Due respect to them. Okay. Where were we? Now, let's understand that if I'm talking about these problem statements, how we can leverage quickly, the kind of CNN infrastructures, right, or the architectures. How that, mm, let me pull that also one for a few seconds.
So CNNs are capable of solving deep neural network as well as vision problems. That's why it's called CNN, right?
Yeah. CNN is like convolutional neural networks, right? So uh, that's more to do with hidden layers, which are having the filters, right, attached. This CNNs can be also utilized for text data as well. So, but that is taken in a different way. You have images, you have text, you have OCRs, whatnot.
Okay.
27 is this, 28 is this, where is 29? Okay. So let's understand this. Seven is this. This is 28. Now, if I see now, let's say how we are actually working on images end to end, right? We'll come to the augmentation part also, and there are processing libraries which are there, as I mentioned. You can leverage OpenCV basically for maximum things, right? But there are some other image augmentation libraries as well. Let me show you first image augmentation. So some are freely available, some are paid ones, right? So there is something like albumentations, right? Albumentations. So there's album and its augmentation. So what it does is basically it's a fast and flexible library for image augmentation. Okay. So if you are working on a classification or a segmentation, object detection, for example, I work for railway industry where we have to detect objects as well, like something is there. If automated trains are going to work out, right? So they need to have some kind of signals to control the speech and all. Object is there, which exactly we need to see. So if there is a cattle or any particular object coming on the track, that detection has to happen. That's separate from classification because sometimes in a classification we are talking about few classes and max some countable number of classes. But when it is object detection, we need to identify that it can be of any category. It could be living entity, it could be a, a box, it could be any material, right? Anything. So object detection is slightly different from classification. Why so? Because we attach some boundaries to that. We have something known as area of interest. So that area of interest in object detection is very important. That we don't do in classification. Classification is just classifying an object, whether this is this or that. Now, what portion is this and what portion is that? It's that kind of a difference. So it's object detection, right? And yeah, so what this documentation in this library can help you with is to work on, let's say, each and every use case. Video augmentations also they work out. Semantic segmentations, object detections, bounding boxes you can work out with, right? Now, uh, there you can see there are so many kind of examples, right? There is something known as text image. There is multi-target, mosaic. Let's see the tile like kind of workaround. So if they have shown object, right? So you can see that this mosaic can be created, right? Just to identify it. It's not only identifying the object, but also helping us to get where exactly the different components of the body parts or object is lying, right? Then it could be multi-target, right? They have not provided the code for this. Why this code is not available? They have given the example. Okay, bounding box, let me show you. So bounding box and all these things we created, when we were working for a traffic, like identifying number plates, identifying the major issues with the traffic rules. All those things can be worked out on the loop. So you can see that with the implementation, we can identify not only the object, but what is the hidden component, and we can label that also additionally. So agent can understand. Even if you want to build a robotics, how a robot will understand which is a left eye, which is a right eye, and all those things. So you can see that this is a big problem statement to actually understand what the object is, what are the different components of an object is, and for that these kind of libraries are utilized. In a factory, whether a particular factoryman worker is not, or supervisor is not having a helmet, right? So it can also result into accidents, and during that it could be a major injury. So people are implementing to capture whether there's a helmet or not helmet, that particular person is wearing. These are major, minor, I should say, kind of implementation in CCTV. If there is something as a
Sorry to
pilferage is
interrupt
basically
here.
handled. Sorry.
We are hearing a background noise and unable to concentrate. Sorry to interrupt.
Okay. Now can you hear me?
Yep.
Is it a background?
The background, in the sense, someone was talking, I mean, kind of a thing. That's what I know.
No, no. I mean, are you able to hear anything right now?
Yeah, now I mean, it's good.
Now it is
Do let,
better.
okay. Do let me know. So what we are discussing, so there are multiple, libraries coming in. Few libraries are augmentation and image augmentation. PYPI. This library deals with multidimensional objects like 2D, 2D and 3D as well. So it's made for entire TensorFlow workarounds, right? So this is basically the library which you can also majorly utilize. And you'll have the GitHub repos for this kind of things, right? Now, what we are doing is, let me tell you. Before image augmentation, let's first of all see how image is basically handled. Though we have discussed this multiple times, but since we are starting fresh CNN part 1, let me again discuss. So as you see, there is an image, okay? There's a full size of image. So cat is not only the object, there could be a number of things in the environment. So we can see that there are 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. 6 cross 6 kind of a matrix is there. The cat is covering 3 and let's say 3 cross 4 kind of, space between that or in the center of that particular entire region of interest. This is my entire area of interest, and within that, this is my major object I need to detect. So if you select a 3x3 filter, this 3x3 filter will take this part, this part, this part, and this part. So 4 times it will stride up and down, left and right, and will get the object from 6x6. It will at least go to around 2x2 kind of a thing, which you can further inflate and can make it one-dimensional, right? So that's the objective which we have seen most of the times. Input image convolution layer, then you decrease the size of this image. It could be multicolor image, so you can see multiple RGB frameworks, like 3 channels could be there. If it is black and white, it would be 2 channels, right? And basis that we get the final linear one fully connected layer. That's the output layer. This another output layer having 5 neurons will be compared. That could be a dog, and we'll see the match. So tail will match, everything will match. Only the shape of this or the area of this particular region will not match. Else you will not be able to see much differences unless you are seeing some spots and other things, right? But yeah, with this same silhouette is like the body shape of this particular object versus another object which comes in. So it will be very difficult for us, for AI at least. So it's inspired by a human visual system designed to handle spatial data sets efficiently, and it automatically learns from the hierarchical features from images. It also helps us to transform how machines are interpreted and visuals can be generated. Now, the key layers in the convolution layers are basically number one. I mean, in the CNN algorithms are number one, the convolution layer itself, which means that I can work on extracting edges, textures, patterns using the filters. So I can have the edges, textures, and patterns. Okay, multiple things can be captured because that matrix will capture a certain portion of that image, and therefore it is going to have that feature. Then there is a pooling layer which reduces the size of the image shape, which was already there. So for example, this is right now 6x6, making it to fully connected layer. It's happening because pooling layer was there, which pooled the or reduced the size of that shape. I mean, the particular image. Fully connected is nothing else but the last layer, which is one single linear unit to compare with the another one. And the activation functions, which are majorly ReLU in this cases, because there we get so many minus values. To reduce that, we just have the values to be in the limit of 0 or maximum. So the extraction and let's say analytics process is nothing else but you just have the input image, attach convolutions, do the pooling. Pooling is nothing else but calculating the mathematical scoring. Either it is average pooling, max pooling, which we have seen, and take those values, reduce the size. And there's a deep layers. Like similarly, you can again have a pattern of convolution pooling, convolution pooling. You can attach 20, 30 much layers like that. And in the end, you can classify with fully connected layer. That same thing. Why CNNs dominate computer vision? Because automatic feature learning is there. Parameters efficiency is basically worked out. Because what are parameters? Nothing else but the weights and biases, right? And they get finely tuned with respect to the architecture of a CNN. We also get the spatial understanding, especially for images, video, and even the GPS kind of data sets, right? Especially in the geolocation-based data sets. So we can use satellite imagery also and have that kind of analytics using CNN. It has a built-in invariance, which means that if there are rotations in the image, scaling of the values of the pixels of the images, right, that is to be changed or to be altered. We have to maintain that particular normality across the transformations. So there are built-in functionalities within the model in computer vision, especially CNNs, that they can handle those normalizations easily. So the pooling is doing that task while keeping the sanity of the data for the image and not deviating a lot from the existing architectures. The real world examples I have given multiple. So face recognition, medical imaging, self-driving cars, all these things are actually equipped with computer vision. right? So CNNs don't see the images, but they understand them, right? That how exactly the humans can do that work around, right? So ResNet, Inception, Efficient Net, these are all the different algorithms, and that's what we are going to see now. And in the collinear vision neural network part 2, we'll see how YOLO also can be utilized. So CNN part 1, we're about to begin. And let me come back. Okay, I guess. So if I go back to my so please tell me, have you done this exercise? The cats and dogs classifications using CPR10 and CNN, right? I think that we have already utilized. I don't know. I mean, I believe so. Maybe you can validate. But I thought we already discussed the C4. Please tell me. Are you able to hear me? I can't hear anybody.
Yes, Ravi, we can hear you.
Okay.
Uh, I don't remember, but I need to go through the last session, which I missed.
I don't know. I mean, I could remember, but anyways, let's see that once again. And let's see if I have. '28 I have assembled here. 28 is this. And so let's say we take a very simple example of CNN, that how exactly the CNN architecture is working. Hope you can see my screen with the code CNN for cats and dogs kind of classification, for example, to begin with. So we have dataset.zip. It will take some time, so I'm not going to, again upload it, but you can see the output as well. So once you're uploading this, you'll see that there are 8,000 files which are belonging to two different classes, and there are 2,000 files belonging to different classes. So training and testing kind of data sets would be created. So what is the training set? The training set is data set. Under that, there is a training set, and testing directory has the data set, which is testing data sets. 8,000 versus 2,000. Sample images of mixed images of dogs versus cats kind of scenarios. What we have to do is we have to leverage TensorFlow and within that Keras and utils to work out on pulling the images datasets from directory kind of functionality. What it does is if I have image dataset from a directory, it will pull that, identify that it's a dataset coming from the images perspective, and the datasets should be compressed because it's huge number of memories could be utilized. So we have training data directory. Having a batch size 32, you can alter it as per, it's a random process, right? We know that. Image size is obviously like 150 cross 150, that you can get it from any source which you are downloading the data from. If you are dealing with your company datasets, please identify the pixels, the dimensions at least, how they are doing. I mean, what is the kind of pixel and all. For that, you can use any automated tool or computer vision's OpenCV also you can leverage to get those dimensions. We'll see that in image augmentation part, that how do we handle those things, right? Shapes and size, and we can compress that. Versus there is 224 cross 224. So it's a bigger image, and let's say it's a small image kind of a scenario, right? So identify 150 cross 150 image size, keep it. You can change that, alter that here, right? Label mode is binary, so we have the binary labeling. I'll show you how exactly the data set is being labeled. And same, we can create it for testing data sets. As of now, we need to work out on TensorFlow Keras models. From that sequential, from last few weeks, we are always using Keras which is incompatible with TensorFlow, and there we are using sequential modeling. And under that TensorFlow Keras, you are adding the layers. This is input, dense, flatten, convolution 2D, max pooling, and rescaling to maintain that robustness and invariance part. So can somebody let me know now, since we have discussed many times, what is input, what is dense, what is flatten, convolution, and max pooling, the concept at least, not the library part. What is the concept we are doing there? Using there. Any? Why this input function is used for? Hey team, anybody can let me know, please. Can you hear me? Hey, can you hear me, guys? If yes, then please can you?
Yeah, input layer defines the shape and format of the data.
Okay, so input is just the what input or the neurons we are going to handle, correct?
Yeah.
So it is the basic object, like my images, it could be text. So it's basically the input neurons, right? Then dense is what? Dense kind of neurons, what they do? This function.
It learns about weights and biases in that layer.
Okay. Or can I say that it's majorly to do with creating the multiple layerings, right? For example, hidden layers, activation functions, right? So let me show you. So if I'm starting a model, I'm adding. Everywhere you can see the common function is dot add. What do we add? First of all, the input, that is the object itself. Second is any additional function like rescaling, any additional layer like convolution 2D, another layer max pooling 2D, another layer convolution 2D again, then pooling again, 2D again, pooling again, like that, like filtering and pooling. You can take it multiple times. You can also complex it further if you're not getting proper accuracies. That's what the magic is. And then in the end, we are still adding the flattening. That fully connected layer is what we again add that layer by using simply the function that is flatten the input which is coming in from the previous layer, because this input is passed to this input is passed to this input is passed to this. These are all connected layers. And in the end, we use dense function. This dense is basically to attain an activation function and create a fully connected layer with respect to the flattened layer. Flattened is what? Just flattening it. Fully connected layer means now matching one object with the another one. For that, we need FC layer. So flattening layer is what? Just lowering the dimension of previous layers. And dense is basically where you are creating the neurons with respect to the activation functions, so that it acts as a function fully connected layer. You can match it with another layer of the same object, which is working in the separate panel. And then what you do is, again, you add the final output layer, that's activation with sigmoid, so that you can classify the object, right? So this add is there, input is there. Rescaling is just to rescale the object size to 0 and 1, because we have 256 kind of shapes. I mean the let's say the different values of intensities, right? 0 to 56 we work in the bitwise operations with respect to the image handling. And there we see that every object image basically is having the red, green, and blue kind of channels, where every channel has its own intensity ranges from 0 to 256. So ideally it is 0 and therefore 255 in the end. So it is 256 kind of patterns, or let's say intensities values. Now in short, what we are saying is we rescale it. So we are just dividing that particular object by 255 for every input neuron. Okay, 150 cross 150 cross 3 because it is red, green, blue. Okay, Two, it is black and white. After defining this, what we are doing is we are just compiling. Okay, you can tell me why we use compiling from few sessions. It's not obvious, but what is the major utility? The compiling function itself will help us to assign different functions which are coming from the keras. For example, there is an optimizer, there is a loss, there is a metric function. We can compile them all together within same, let's say, argument. I mean the parameter setting, where we can attach them all together to get the model sum. So we can use model.compile, apply all this to the model, and create the summary of the model. So summary of the model is that model is sequential, it has rescaling done, and it has got convolution 2D, it has got maximum pooling 2D, it has got convolution again, pooling again, blah, 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 blah. Like that, total number of parameters which were there trained in this data is 487 and 481, like numbers, right? 487,481 kind of parameters, which consumes 81.86 MB of memory, like that. So trainable parameters are this. Now, in the end, we are fitting this, let's say, the model with respect to the change in epochs, the change in batch size. Batch size is kept at 32. You can change it and see what is the result. There is a validation data set, which is testing data set. And we are having a plot keras, plot losses of keras and TensorFlow is a function to get those particular callbacks, basically the visuals, along with the epochs. So we have multiple epochs, and then we have x-axis, y-axis as the kind of, the accuracies and losses. So epoch is 0 to 16, 20, whatever we have chosen. So we have chosen 20, and accuracy is tested, loss is checked for these kind of epochs. There is a huge divergence only at this juncture, where it was like a couple of epochs only. Or for, we can see that it's even before second epoch, right? It's something between 0 to 1 kind of epoch. So very quickly we got this convergence. After that, this all deviated. Not a good model, obviously. And let's see the accuracy. So the accuracy is, okay, it's 99.32%. But when the epoch size is at 23 out of 250, we are getting this loss and accuracy values. Okay. If you are completing that entire epochs with respect to the multiple steps, so we have 358 milliseconds per step. Loss was calculated was very low. That's 0.227. But it is all to be done with respect to these epochs. Otherwise, the convergence which you see doesn't make any sense. So select the right set of values there and check how exactly we can further tune it. There's a very, I should say, baseline model of a architecture. Where is CNN? How do we say there's a CNN architecture? Hey, please tell me why exactly we can say that, and this going to be a CNN architecture for the model. Can you hear me?
Yes, Ravi.
So how do we say that this model is a CNN model or a family of CNN model?
We are repetitively applying the layers, right? Or is it that the reason we call it CNN?
No.
That's
So
already
whenever we are using 2D filter or max pooling, this is a part of CNN architecture.
Okay.
Right? You remember?
except CNV 2D and max pooling 2D. It's if you are removing these parts, that means it's a deep neural network.
Yes,
That's it.
that's it.
Oh,
So the major functionality of CNN is to apply a convolution matrix, the filter,
Convolution.
and lastly the pooling part.
So the last results are not accurate, right? The final accuracy based on the graphs that we see, the convergence, the final value at the end.
Yeah. This, see, the final value, if you see without a graph, at this epoch at 23, you are getting this accuracy. Even at 250, if you complete this, you get that accuracy. But when we are saying that we have created a till 20th epoch, this was the result from the plot loss. Plot losses Keras TL.
Okay, so at the bottom you ran 250 epochs.
This one, right?
Yeah.
There is no stop loss, right? I think we are not at all set a stop loss. So if that uh, early stopping is there with a loss setting, then you can even stop it early.
Okay.
Full-fledgedly, it is working with 250 kind of iterations within the epochs. Like epochs are 20, but the 23rd iteration itself, it's getting some better results. So
Okay.
let's
So
yeah.
the
So there
rest.
are three things: batch, iteration, and epoch. If you see this epoch till 20th epoch, I am finding that at this juncture itself, like the first epoch itself, I think I'm closing it, right? Even we started and we closed it very soon because we don't get further the same thing. But the lowest particular error is available with a training data set is at this level, right? Now we need to understand when I'm saying the lowest result, there's a training loss, which is the lowest loss. But when you talk about validation loss, it is the
That is
poorest one.
very high. Yeah.
Which means that when the epoch was 60 and whatever the iteration we are talking about, accuracies were fine. But with what? Accuracies were higher for training data sets and less for testing, which means that it's a overfitting issue.
Yeah. The training is giving high. Yeah.
And here, if you see the accuracy, that's same thing. It's just that the accuracy of a training data set is more than the validation data sets. So this 99, you can see, you can match it from there. So that's why we call it. It is good to work out on training data set, but when you actually implement it, it will fail. That's the problem in overfitting. So it's a false calculations. I mean, false results.
False positive.
Yeah. So we see that okay, it's 99.99% accurate, right? Doesn't make any sense because it will fail in validation. The thing is,
how do we
because
correct
your training data set was that huge, it captured everything. And when you again implement it on training data itself, accuracies would be definitely higher. But when you go for a random check testing set, it is not performing because that data size was less. It couldn't understand the pattern, therefore it cannot predict.
But usually that's the approach we follow, right? 80-20 or 70-30 rule.
I mean, yeah, that we can't do anything. So the rest of the things you can do is you can apply regularization rates, dropouts, and all those things, right? Drop connects, which we learned.
So regularization and all those need to be applied to improve this accuracy, right?
Yeah. I mean, lowering the training data sets accuracy, it's like that, and also stabilizing it with respect to the testing.
Okay.
So validation accuracy, if you see, it's how much? 72% only. There is a huge gap. 93 versus 72. It's a
Not
huge gap.
acceptable, yeah.
Even if it is 72 and 72, we can still agree to that. Okay, 70 is a good accuracy, but it has to be stable. For training also it is same, and then testing also it is same. That consistency has to be there.
But with CNN, I think it would give better results, right? Why this is, I mean, this kind of...
No. So CNN also, what architecture we have written, like it's like, it is very creative thing. It's nothing to do with more logics. How you can further add more layers, it's an iterative process. So maybe you'll get your answer. That answer is what? let me use that model which has got every understanding on a given set of images. So therefore what we do is, okay, let me have those VGG16. Okay, let's see that. Inception. So what I'll do is I'll go to this pre-built model. CNN pre-built architecture is VG16. For example, GPT model, we say OpenAI GPT. That's a pre-built, right? It's already built up, pre-trained.
Hmm.
I'll use its learning in my images. It's the only thing.
Okay, so already popular and well-performing models you pick,
Yeah.
you run on those.
Take that and then run it. So therefore, there are so many companies also training these things and all. But YOLO is common to that. So YOLO, what is that version? I don't know. I mean, after this agents, we are very. I mean, it's very difficult for capturing the other aspects which are old ones, right?
So YOLO is developed by who?
So it's an open source, right? So YOLO is basically, you can see that it's like researchers.
Okay, open source. Okay.
So, right, you can see that this is an algorithmic workaround of few researcher scholars. And then they framed a open source platform, YOLO.
Hmm.
Okay. Now let me give a brief because next session will be purely on YOLO. So YOLO 11 is the current version. I think that's latest IC 2024. So Rahima Khanam and all these people have worked out and the enhancements of YOLO 10. So first version was 215, 16, 18, 20. I used till 8. 2023 I was it was the last model which I used. After 23 till now 25 and is going on. I never used YOLO for the real-time problems. It's multimodalities which we are using right now. Okay.
Hmm.
So what was the task? Object detection, basic classification. Object detection, improved classification. Multi-scale detection they started with. This company, the platform they provided with basic object tracking, instance segmentations again, object detection, nothing much. Maybe accuracy they improved. Today what they are doing is object detection, but maybe they have what they have done is they have used GANs here. Let me see if they're using multiple in the coming version. YOLO and LLM model. Yeah. Can you see that? So they have improved over this year only, 19th March 2025. So improved YOLO 12 with LLM generated synthetic data for enhanced apple detection and benchmarking against YOLO 11 and YOLO 10, which means that what I was assuming is correct. Even now they are started using the LLMs to create those fake images and train them accordingly. So YOLO itself can be improved, which is CNN based workaround.
Okay, so they create their own new images and train the model.
You see, they have what we were discussing in the beginning of the session, augmentation and all. They have implemented it.
As per your experience, how accurate that will be? Creating self images by AI itself and then training.
No, so this I practiced in 2018 actually. When I mentioned one example long time back if you remember, I went to one of the companies which was dealing in the space technologies, right? What they asked me to do workout is to uh, devise a mechanism by which we can monitor the electric wires across United Kingdom. And those electric wires, actually, it was difficult to track because helicopters were used to monitor them, not even drones, because that could be a remote area. So they were trying to do something with satellite imagery and all, right?
Okay.
At that moment, what I did is, so I used autoencoders to create because they wanted to understand that whether if they use some kind of image scans, how to see that this is a fault wire or a correct wire. So that moment I created autoencoder based faulty wire images. So images could be there, but how that correct wire can generate faulty wire images. Then we trained a model on that. Can you relate now on your problem which you asked? So here we don't have any instance of such kind of scenarios. How do you get the images then? Even AI don't know. So you can use AI itself to see some simulations, and maybe you can generate that output. For example, if you see, if a common man behaving normally, how to identify he's a thief? So what kind of behavioral tactics you should see in public the person is having, which can classify him as a thief? That is psychological, behavioral, physical kind of analysis, right? Physiological analysis. So even what we were discussing is being implemented at YOLO level also. So even YOLO latest, what they have done is the researchers further configured it. They use Dolly, right? I hope you are aware, right? Databricks, Dolly, OpenAI, Dolly, and this. So this purely working on image sections. Create original, realistic images and art from a text description. Right? They used it. What did it? So they have apples, right? They have to identify apples. They created with prompts multiple images and then implemented that, whether it is correctly detecting it or not. Which means that now the model CNNs could be embedded with multimodality also. Let's see. OMG. This is what? This is 2015. What they say is multimodal convolution neural network for matching this, right? Not the current one, because it's 2015 I see. What I need to do is multimodal LLMs and CNN. So do you know even this? Okay, Dolly architecture. Let's identify Dolly architecture.
So basically, this generates an image based on the user input as a
Prompt,
text.
right? The text is and image mixed modality, right? Multimodality we call it.
Yeah, that's what even Google Gemini or even OpenAI does, giving a input on, this is my source system, this is what my target system means, it will create some diagram out of it. Yeah, I've done.
So there is a text encoder. I'll discuss this encoders. Coming upcoming sessions are there on LSTMs and all. So encoder, decoder, bidirectional LSTMs, bidirectional BERT models. All these are the baselines to this. So there is a text encoder, which has got, but how they have trained it, it's to be understood. So what they have done is they have done the same thing which you are doing it for neural network. The only thing is their data was huge. So they used images data set. They used autoencoder kind of understanding, diffusion models basically. And then they were trying to match those images with respect to text. Same thing. But today now they are generating at a faster pace because they have crossed the limits of data. Right. That's a large scale deep neural network or large scale CNN infrastructure. Matching text and object. You can create your own, right? If you write something, match it with any given image. How do you generate? The thing is how image is generated. To get that basic understanding, you need to learn first auto encoders. Okay, GANs. Is also a latest paper. So there is a synergistic framework leveraging autoencoders and generative adversarial networks (GANs) for synthesis of computational fluid dynamics results in foil aerodynamics. So what they are done doing is there is an input, putting the text workarounds, everything accordingly, that input against that, defining it, and creating a decoder, generating the output. What is the output? Can you see? What is the magic behind these kind of algorithms? Tell me. I hope you got the reasoning right.
They're
Why I'm discussing this?
reducing the dimension and then again
Yeah,
generating the same image in the reverse order.
exactly. So use a text, define the images, again regenerate. So what is happening is I have an encoder layer and a decoder layer, like how we transmit message, right? We encode and decode accordingly. So translation, or how translation is happening. I want this text to be converted in Hindi language, English to be converted in Hindi. So English return, define that this is English Hindi, matching that, and then decoding it. You getting it? How you convert a language? I mean, how you practically do it. If somebody is coming from Japan, they have Japanese understanding, they don't understand Hindi. You'll have a person who will first of all encode everything in English and then will define it in Hindi how they're writing. So it is indirect conversion of Japanese to English, English to then Hindi, or directly Japanese to Hindi if both persons are knowing Japanese. So same way agent is also working.
I have a question. I mean, let's say English is a 26 letters, but when it comes to Indian language, we have more letters, particularly in Tamil, 247 letters. I mean, how does everything can be exactly equivalent in that case? The
No, no, there
layers.
is you don't have anything apart from a dictionary then. So you just use the dictionary and the grammar text. That's it. So dictionary is comprising of all such kind of things. We call in Tamil, there might be Tamil dictionary, correct?
Yeah.
Let's see. So there is a English dictionary, there is a Japanese dictionary and Tamil dictionary. If you just align all these three things, you get a mediator as English, right? If you are aware of English and you are not aware of Japanese, you will convert it accordingly using the same agent. If you are Japanese, you are knowing English, then also you can do that. At least one common ground truth is to be required. Otherwise, it's very difficult. You can't imagine. Okay.
Okay.
I think
Overall, according to the picture, we have an encoder and decoder having the same set of level of layers in the left
this
to right.
follows that, yeah, this image parameters, if you see, it's all same almost. See, this is again reworking, right? Flattened, unflattened, work out accordingly, and then generate the output. It's very complex, by the way. Same things, every block you're seeing works. So, I mean, what you do is try to see the read those kind of research papers, right? Otherwise, it will be like we will be debated a lot. Few of the research papers you should identify from your side. I mean, it's not only learning the algorithm coding or something. It is that how innovatively we are using this kind of tools. Can I have a CNN now with respect to knowledge coming from a LLM? Then we can safeguard CNNs. Even LLMs are devised of these kind of encoders only. Don't you think so? How LLM would be knowing it? That I have to generate a coffee cup because there was an image and a text earlier. Model was trained on it, and it has been given multiple such images. Animation tools are used to then further utilize it. So it's not big thing. Same mathematics, nothing complex. The only complexity is architecture connections. This is the crux. So what it does is generative adversarial networks, GAN. These are deep learning neural networks only, right? But what they do, they generate synthetic data similar to real world data. That's why GPT can do that. So they have not done anything bigger than collecting large pool of data and using the same previously used data sets, I mean models. So these image generators are composed of generator and a discriminator. Generator takes in random noise vector and generates fake images. And then discriminator tries to distinguish between actual versus the developed one. And what if I have attached a reinforcement learning? Whenever the discriminator is not working correctly, I mean, where a discriminator is getting some poor results, try to tune that. Whom you will tune? You'll tune the generator, isn't it? So generator is to be tuned. Who will tune it? Reinforcement learning will tune it. But on what basis? On the result of discriminator.
Discriminator is nothing but the feedback, right? That reinforcement learning gets.
Discriminator, you can see it's basically again another layer. I mean, you can definitely use the human in the loop or agent also at the same time. You can also create a reinforcement learning based human in the loop, which I mentioned right now, which can be metric based workaround. For example, if I had this object parameters, I can define them. And whenever a deviation is there, I can see that what deviation is there. It is physical, physiological, what kind of deviation it is in the object. So it could be automated, it could be human in the loop, both.
Okay.
And what we do is we just use the same logics to differentiate the losses, right? What we say, optimize the losses. There's a bigger architecture and let's say the discussion, but yeah, I would wish that if you can go through detail, maybe in next session, whenever you are there, you can have your findings. Would be good to present at least from your side, if somebody can take that initiative. Share this. So it is the modern version of CNNs, right? And modern version of GANs is GPT based models. And let me. So GANs, variational encoders, transformers. These are the. This also you can refer to. Still opening up. Just a second. Let's see what is in the session apart from this. So this is second part, right? This also have to teach you separately. Diffusion models, right? Just will take some time. These kind of models are also good to learn. So let me have some time and space blocked for it. This I'm sharing it for right now for your reference, but I'll take it with full exemplaries. So GANs and Dolly architecture. If you understand this, then you can yourself think of a small language model with handling capacity of images or videos of your industry, and you can work out. It's 2020, right? So can we have a break? I mean, since the week 28 objective was this much only. What we can do is, okay, there is one more exercise, I guess. Just a second. Boolean layer, input. This we have discussed. Real world face recognitions. Takeaways. This we can begin after a break. Data augmentation, boosting, and all this scenarios, right? Okay, can we have a break, please? Let's come back after 15 minutes and we'll begin with part 2 of the session. That's on augmentation part.
Okay.
Can you hear me back? Can you hear me? All back? Sharing my screen again. Now let's understand the image data augmentation part. How exactly we can manually tweak the images. What are the functions? So that was I mean, this is what I was discussing. The problem statement is that if we don't have large label data sets, that leads to overfitting. I mean, uh, that can lead to overfitting, and to prevent that overfitting, we need further supervised mechanisms, right, to label that correctly. Now, how we can build these strong models with limited data sets. So one thing is that we can expand data sets with transformations. For example, we can have a methodology in place where we can artificially expand the data by applying transformations while keeping the original label. So dog can be of different size, shape, color, variants, species, right? I mean, not species, but I should say the categories. Uh, so within one species itself, there could be multiple physiological changes which we can observe and we can label them. But how do we do that? One thing is that we can alter the images without changing meaning of it. For example, we can have a dog with different side poses and shapes. So we can have a rotation. So it can change the angles between 0 degree to 360 degree. Flipping is another transformation which we do. That is horizontal or vertical reflections of an image. Cropping and zooming, zoom in, zoom out, and crop so that you can select and can see if some better results are there. And then translation as well. We'll show you what is a rotation to translation, different types of ideas, right? So the idea behind this is that meaning is not changing, only the transformation is there. So a flipped cat, if it's there, or a transformed image is there, it's still that same image or a category. As in, if it's a flipped cat, it is still a cat, right? So there is no difference over there. And how we can do that? So let's simulate. There are color and filter augmentations possible. So you can simulate the lighting and environment changes to make the models more different and robust. So you can see that this is the terrain of mountains, and we can increase or decrease the lights falling on them so that the object it still looks same. Only the background, the color, the picture, the pixels, they can change, but shape is almost same. Even if you want to take a small portion of it and can match with the another one, that also you can do. So I mean, this is all mathematical workaround. What we can do, we can color space, do the color space adjustment, increase brightness, contrast, saturation, and hue, the different colors. Black and white also you can try to do, and apply the kernel filters for reshaping the and sharpening the blurring. And randomly you can erase the part of images also, see if it is working. The other is advanced augmentations apart from flipping, rotation, and all those things are image mixing, GANs, and style transfers. Image mixing is we can have multiple images, combine them all together with similar kind of image meanings but different shapes. You can generate new or artificial images, that's GAN, generative adversarial networks, and you can have style transfers. So you can add the styles which keeps the particular content intact, but yeah, the style is different of that image. We'll see these examples. Now the major challenge behind augmentation is that, and especially for sensitive areas like medical imaging. So medical data sets are less, they're costly, sometimes they're having the PII kind of things. So because it's a patient, it's already diagnosed with a disease, and some diseases are actually people discriminate against those diseases, so that's why it's kept secret and not socialized a lot. So that is the ethical limit which we have. So flipping, zooming, color shifts, that's what we can see, but it only is adding value to the model by increasing the accuracy by 14% only. That's it. Sometimes if you change the medical imaging, it will lose its information. For example, if it's a cancer cell, you need high definition image only. If you blur it, those edges and those kind of crests and troughs cannot be identified, which can be carcinogenic, right? I mean carcinogenic cellular architectures. So therefore, it's to be handled with care, especially medical imaging transformations. What are the libraries? We can leverage ImageAug, Albumentations, which I just shared, Torch Vision. These are the popular libraries. What do we do there? Random flip, rotate, zoom, rescale, right? Change the size, shape, etc. like that. That's it. What are the best practices we need to have when we do the image augmentation? The do's are that we use transformation suitable for domain. We need to keep object recognizable. It should not change the meaning. It should not change the object. Whatever the validation metrics are there, it should be there to check the strategy. For example, if I change a particular object by XYZ percentage in terms of resolution itself, that resolution should not deviate the meaning. Secondly, there should be some standards of resolutions which we need to maintain. So those metrics we need to define for validation, for flipping and everything. Whatever you see, especially in generating the new images, you have to by yourselves create those metrics. What should be the cropping ratio? What should be the standard coloring? What should be the hue percentage, transparency, and number of parameters, and balance the variety with realism. Don'ts are like avoid unrealistic transformations. Obviously, yes. Don't over augment. Over augmentation will lose the context. Avoid vertical flips for text and faces. What is vertical flip? So dissect the image into two and then see if you are flipping it. It can change the right side object into left side object kind of thing, and it may not be best practice. So it should be symmetric. It should be of same object. It should not deviate the meaning. What are the future aspects? Auto augmentation, it's already happening. AI finds the best augmentation. That's it, we discussed. Combining traditional augmentation with synthetic data for a stronger workaround. YOLO 12, with that research paper working on Dolly is basically the example that hybrid methods are now available. You can democratize AI, like enable the advanced vision tasks in data scarce settings, which means that I need to socialize this thing, especially when it comes to a very sensitive areas, and need to help. Then in that case, you may have to even serve free of cost many a times, right? That is right democratizing AI. It's the right side of democratizing AI. Make it something for good. Try to build your augmentations without sharing personal information of anyone, without hampering their particular sensitivities and I should say emotions, and try to play with safety in terms of AI and unlock your model's potential, right? How come? Practicing the augmentation exercises. Any doubts so far? Please confirm. Anybody?
So the methods or functions that will be used will be different, right?
Yeah, I mean, if traditionally these are on the left side, if you can see flipping, rotating, applying, zoom, and then let's say these are the basic ones, right, which we used to work out.
Yeah. So what are the libraries these will be using?
Yeah, so one is you can leverage the, as discussed, the uh,
Keras?
augmentation, right, which I showcased the first data that is, I mean, image augmentation library that also you can use. So that's the basic ones, right? And if I show you same exemplary with augmentation practice, and let me give a demo of each and every library also in here. Let's do this exercise, right? This is a classification with image augmentation. How come? Data, you know that what are the pixels and what are the metrics. Same data I'm using. Build input pipeline, build the model, train the model, test the model, and improve the model performance, right? By giving the proper feedback, changing the parameters. So what you're gonna do is, let's see if this takes less time. So I'm taking right now from Keras, pre-processing aspect of Keras, and that's on image part, right? What I'm taking right now here is Keras, image, pre-processing. And can you see that the resizing, the rescaling, what you're talking about is also available at Keras level. Okay. The basic functions. This is cropping, right? Let me show you some animations before we process the images, right? Image augmentation examples, images. Okay, one single example and see the augmentation. So this is our original image, horizontal, vertical flipping, rotation, blurring, brightening, adding noise, grayscaling or hueing, and cropping. Please continue.
Yeah.
You get the logic? What do we do? Whatever we do, it should recognize the object in a better way so that from each and every angle you see the object as identified properly. This augmentation based work, right? What they do? So every library will have its own USP. So if I see this, it is blur, median blur, gray, compression, brightness, same functions. Gamma is added. I don't know. I mean, in most of the cases, you try to work out on the saturation part. So how much is required, that basically is subjective. I need something benchmarks, right? Okay. So if you see now benchmarks, right? What are the benchmarks or metric criterions which we are discussing? And what they do is basically is they have top 10 speedups with respect to this library part I'm talking about. This is implementation benchmarks, right? So what they have done in the latest versions, whatever they're doing is they have improvised or speeded up the operation on blurring, dropouts, queuing. Padding is like assigning the additional spaces, brightening, motion blurring, grayscaling, contrast, and adding a shear. So, sorry, there is that. Okay. Now what I'll do is whatever, let's say, image identification, I mean, image categories you're not able to identify, please let me know so I can show you the sample of that. For example, there is silhouette also, which people use a lot. I used to have it earlier, but I'll show you. So, okay. What has happened here? In contrast, limited adaptive histogram, which is CLAHE in short. I again repeat, it is contrast limited, and adaptive histogram enhancement. Anybody?
Is it,
This processing, what is happening?
is it enhanced? I mean, is it gamma or something that is the value is increased?
So it is first of all contrasting, right? I mean, this is a dull version of it, and you are adding light to that, intensifying it further. So you can clearly demarcate the differences, right? Let me show you. What is the process here? So MATLAB and Simulink also, does the same for image processing. So there is a particular tile. We generated tile, right? All the coordinates. Then there is a histogram which is being created on the pixels and the distribution pattern. And what we do is how we refine it or we add more value to it. If you can see, this clipping is happening. There's something total excess, right? Something which is of the intensities. If you talk about, these are very minor, less number of observations. Maximum observations are this point, right? These are few observations and they are at very higher values. That means you can see some observations are outliers as well, kind of outliers. Right? So that excess distribution is basically ignored. What we are considering is the maximum distribution here. So that distribution pattern is then implemented back. So you get that tire visibility in a bit. Do you know what stats is doing? Creating a histogram, and on the few observations which lie under the centralized normal distribution curve, avoid those by clipping into a certain limits. Use maximum observations, that's it. Maximum observations which are having the PDF values as per the norm. I mean, as per the distant class practice.
So in the back end, so the hue values, they are increasing, right? But
Sorry, which values?
how they are improving the image, I mean, the contrastness.
Okay. So you can see that there are few values which were there, which were sort of outliers. And what is this outliers? Intensities were outliers. Means you are avoiding some unwanted intensities. Maximum intensities are retained, which are actually defining the object region and adding a contrast to that.
Okay, so they just adding extra contrast to the existing image.
Extra contrast and retaining highly large number of values which are significant, more number of values but they are insignificant are dropped actually. From you can see there are multiple observations, right?
Okay, less intensity
Remain.
area has been dropped, and the focus is on high intensity area.
It's like, I mean, I can't show it my how to say, I can't zoom in. So if you just try to zoom in and zoom out. It's like that, you know, additionally.
Got it. Got it.
So that zoom out is what? Zoom in is zoom in is what? That you are reducing the unwanted values. You are increasing the wanted values. But that is happening statistically.
Okay.
Right. First image, you can see this is the case, right? Second image, few observations, right? I mean, these are being deleted and this is highly compact. So their contrast is added. And few observations they are dropping so that you get a clean face. This is also another example. You know, you just see the few values. Those contrast, I mean, compact values we are avoiding so that we can get more clarity. It may be adding a noise in the image. It's like that, you know, denoising.
Okay.
Everybody got it? What is happening in the Clahe? That is the contrast. And let's say the contrast limit, adaptive histogram. That's it. Enhancement or equalization, you can say. Anything else apart from this on the augmentation side which you wish to see from these examples? Because this you can understand only when you see the image. Let's take a couple of them. I mean, two more. What is the next which everybody is saying that I should understand this, how it is happening, what is happening there? For these features, this library has speeded up processing. These features, it has downgraded it. Anybody? Shall I show sharing, how sharing happens, or you are aware? What is sharing?
Yeah. So that,
That's physics. I want that. I mean, instead of shear transformation. All right. So what is also happening is we are having the geometrical aspects to the images. So we can have a rotation, we can have transformation, translation, a replica. We can have uniform scaling, non-uniform scaling. These are the basic geometrical examples. Under that geometrical transformations, you will see something is sharing. So there's an object. Sharing is shifting from this side to like that right side, you know, tilting it.
is it?
What's right? Okay.
So it depends by the angle, right? How much we need to
Yeah,
shift.
that is skewness, right? So it depends on the stats basically. So as earlier, what we did, we cut down that histogram. This time we are avoiding the centralized values, rather tilting them towards the tail ends. You can imagine. Okay. Because it's all metrics, right? And you can get few observations deleted, added like that. You can change those. These are the mathematics behind all those objects, right? No need to get into that much, right? I mean, otherwise it will be flowing away.
You please share this link.
Sorry.
Could you please share this URL?
Okay. Sure. I think it's pleased. Give me a second. What happened? Antivirus is blocking this. What happened? So, sharing this link in the chat as well. Any last one more last piece we want to discuss? Let me know out of this features of augmentations, what exactly you want to see. First of all, we'll deal with images, and then understanding how the images look like. Then we see the functions.
So again, in this as well, so from 3 channels to we need to convert into only black gray colored.
Majorly to handle that, size, because we are simply adding one more layer to that, right? So at least 2 layers you can utilize for grayscaling is required.
But ideally, what is the preferred approach in CNN? I mean, this is more related to image augmentation, right?
This has nothing to do with CNN. It is a pre-processing, right? So your
Yeah.
pre-processing results, after this, results can be further improved. That's what is the assumption.
Okay.
So transform the images with these functions and then see, like for example, we applied scaling, right? Divide that by 255. So that's speeding up our operations.
Okay.
Nothing to do with CNN. It is commonly utilized. Even if you are applying CNN or with different algorithms you want to track, you can use them. But the best is CNN, and therefore, and second is this research papers are there. That if you have these kind of, let's say, features addition, how much percentage you are improving on the model, blah blah blah. It's all iterative. Nothing is standardized even in that case. But these values you need to standardize from the SOP perspective. Suppose you are dealing with day-to-day activity on this, right? So you are working on a software which does this image processing. So you'll have to set these limits. For example, if you are creating designs in a factory for pumps, pipes, automobile vehicle parts, anything, there you may require all these things.
Okay.
Then there is corner illumination. So sidewise, you can illuminate the images. Let me show you that in Plasma. Those two things. Uh, Corner illumination. Hey. Let me show you. Okay. So there could be in corners, right, in the image, and those glow corners would be having some issues with the lightning, right? So you just illuminate that part. Okay. If I have image, that will be easy. Okay, I think it works. So you can see that on edges or corners, if you go, you are trying to illuminate that portion, right? So there are functions that you can write, which can, it's all intensity based, right? So you can decrease, increase the intensity, brightness, contrast, anything. That's it. So now you understand what is contrast. It is nothing else but the pixels you are having. You are just playing with their values. So you can reduce the light, increase the light, contrast, add the contrast, sharpness. That's it.
Yeah, it's just adding more light to the
Yeah. So corner illumination.
illumination. Yeah, illuminating is light.
What is happening on this? Like, I think something is not correctly opened. Okay. What was that last? Then we have plasma shadow. Okay. Plasma shadow. And all these functions which I'm showing are possible in Albumentation library.
Okay.
So yeah, there are direct functions. I mean, it's up to you how much you program. That's plasma shadow.
So do we have a notebook file explaining few or some of these
That's open, right? So I'll start with this basic one.
okay.
This one only I said, right? We started with Keras only. So Keras is image data generator. This I'll be showing you end to end. How do we flip, rotate? These are common ones, right? First thing. And let me get the library based operation on Albumentation. So you get
Okay.
everything there. Okay. Let me get their GitHub. So you can play with that. Let's quickly see what you can practice. Docs, test tools, Albumentations. So there by default, you can see they're using the PyTorch platform only.
Okay.
These are the things which they have kept. Geometric based mixing, image mixing, you remember that?
Yeah.
Transformation of 3D, blur, cropping, dropouts, that's it.
Yeah, various actions. Yeah.
So these are the functions. So you can pick as per your requirement. So there is a Albucore library. Okay. Let's see that is working on what? Batch transformation. So you can apply this on the entire batch of the samples which we create. Pyrentic is another library which we're using. From there, we are importing after validation, a validator, field validation info, field validator, etc. We'll show you how it works out. And the basic functions, right? So what we do there is, let me show you. Okay, can you see that? Within Albumentation, they are using CV2 only, computer vision 2.
Okay.
Right. Let me tell you what they do then. So it's a sample data. There's sample image they created, right? Created a mask. They created a bounding box, labeled the bounding box. And this is the transformation happening. This is the distortion. So they are distorting an image because this is what they are referring to as distortion. So this library, if you call, will be distorting. Then you need to see if I distort image, what is the benefit I'm getting, right? That's simple.
Okay.
Okay, so there are so many things to work out: the border areas, the internal areas, right? Then let me show you if they have resizing is common. This you can directly take it from this thing. Transform is also not bad. Great. Geometric is already discussed. Blurring, it's a very small one. Okay. Now in blurring also, can you see what are the different types of blurring which are possible? Okay. Defocus, Gaussian blur, which is based on probability distribution of the observations, right? Glass blur, median blur, motion blur. When I say blur itself, you can understand this again playing with a histogram. Whatever the data set is there in the matrix, we are just playing with that, nothing else they are doing in a different way. Be it cropping, be it a dropout, be it a geometric, be it a mixing, be it a pixel, whatever is there, it's only the matrix which you are having from the image or the arrays which are distributed, correct? Everybody got the context? What we are doing is we are just trying some mathematical calculations, trying to improve this and let's say add the noise, blur image, change the angles, blah blah. But I was wondering, I mean, they should have given all this, functions there directly. So in the GitHub repo, they have not given all this, which I see. Let me see in the core if they have given. That's PyTorch based. No. So their GitHub is revealing only few such things. Even what I see is on their particular main page also, they have pulled off some codes when I was demonstrating. I don't know why. So these are the basics which you can handle with the implementation. Now let me see if I do a image shear transformation. Let's see if Keras does start directly. This is typo. And this instead of Keras, let me directly find implementation. Okay. Can you see that sharing? Please confirm.
Yep.
So here you can not only program, but you can also use this platform. You can upload an image, and best is you can, before applying a code, you can try to see this visibly. I mean, with a visual. Okay. So they have Affine, which is applying the transformation to the images. What kind of images transformation is happening? Scaling, translation, then sharing, masking, all these basics. Objective is object detection has to be there proper, even if the images are distorted. That's why even if you're putting anything on a GPT, it tries to identify those things because all these transformation based workarounds are being given to the OpenAI model also. Make sense? Sometimes you might have kept a blurred text. Sometimes you have kept a very small size image. All these things are.
What is this site does? I mean, using this, we can make any of the image manipulations.
Yeah. So you can upload any image directly. But yeah, you can try and you can just log in and see whatever image you want to work out. Just try to add all these functions, right? This is a code also which
Okay,
requires
please
to log.
share this URL also, Ravi.
So today we are discussing on augmentation, correct? And see this one. So I think I would recommend just go with implementation if at all you come across anything from the transformation perspectives. Otherwise, leverage multi-modules. Amazing. All good? I mean, you got it?
Oh, so these are all various kinds of
Transformation,
mechanism where we
Hue, median blurring, inverting, histogram matching, fancy PCA principal component analysis like with images. I mentioned a long time back, right, that images also have the same clustering mechanisms, right, unsupervised. And PCA also can be implemented on that data. Text also can have that PCA, reducing the dimensions. This is illumination, right? Now comes the illumination. Okay. Can you see some areas are illuminated, but I see this is original is much more illuminated than
yeah, that's what I see. It's just reverse.
this is crazy. Corner, let's see what happens in corner, right? Is it getting implemented or not? I mean, there is no submit button, but I think that's
So automatically
oh sorry. No, this is executing transformation, right? So let me apply on a corner. Yeah, this is much more better. I don't know.
original is much more better.
Let me please see. I mean, I can't. Okay, let me also see in between. This got eliminated, right?
Is improved, yeah.
This is good.
Comparably, original is good.
Yep.
Okay, so let's see code also. Same thing. Just use the elimination function.
Okay.
Okay,
Right.
that's it. So I think this is king size exemplary and functions. Nothing to take anything apart from this.
Kind of
Yeah,
a kind of thing for transformations.
exactly. Maybe you can create one full notebook on each and every aspect and then reshare it amongst yourselves for a better practice. I hope this is interesting, right? I mean, you are enjoying this.
Yeah.
Yeah,
So-
Ravi. I have a, in my understanding, where we have a deep neural network that has been evolved into CNN for the image perspective,
Right.
and based on that, further, transformer architecture comes into picture. That evolved. The transformer architecture has evolved into LLM world. That's what overall journey of
Yeah. And
we
now you
are.
can do whatever you have done in the past in a better way. Augmentation, better way. You directly write a prompt and get that. Let's try that, right? So give me an example which you want to see on LLM out of this.
Um, I mean, simple in terms of a giving a word sentence, to make a picture out of it.
No, that's fine. But what you would like to try, like out of these functions?
Out of these functions, equalize.
Equalize, right? And let's try this also, this Clay, right?
Okay.
Let me show you first what will happen there. Okay. You see that there's a contrast which is added. Okay. Let me see if I have a model up and running. There we go. Enter. Yes. Yes, it's working. Sharing my screen. So I'm dropping image here. Okay. I'm showing you what we can do now with OpenAI models or any LLM with respect to image processing. Okay. That's what we are working. So not create. I don't want to create an image. Let me take some sample image. Okay. Apply all functions What are the all functions? Let's see this. Where that one is. This is it. Back. Let me take set into. Oh, I can directly go. Let's see. So I've asked to do whatever they want to do out of this site. So what it is using is PIL and OpenCV for those kind of processings. And what I'll do is I'll create a Python code for this. Okay, don't worry. So then I'll share so that you can check all those functions. Taking time because there are so many, right? This dog is going to get. If it's taking time, I'll trim some. Just implement fly and share stacks and image. It's taking too much time. Okay, give result here. Meantime, I have to do it. Do you see a difference, by the way? Let us see. Right. Okay. Contrast and then details added. Where is my data? Do you see a difference there? Please confirm.
Yeah, the contrast is
Right. Perfect. So original was having main RGB values as this. So you can see that only these values are changing, average RGB matrix, correct?
yeah.
So it has increased or reduced. Average was 120.90. It has reduced by 2 basis points. Then it is,
Oh, it
sorry,
is 129.
120,
129. Yeah.
9 point. And then there is 111 versus 120. So increasing, right?
Yeah.
Okay. So this is easy, right? Now give me code to implement. Okay, no, let me try this. Give me Streamlit code to implement. So you can have your own website right now. All such transformations, uploaded images. That's it. You're getting it. So what we can do is we can create a platform where people will upload that image and we'll get this processed. So what they're using is CV2. I don't have CV2. It's taking time to upload those. But let's try. Additive noise, Gaussian blur, box blur, median blur, motion blur, sharpen, unsharpen, auto contrast, equalize, creating all those defined functions. So behind the scene, every big player is using these basic libraries only. Okay. So today we created an application which can do all this processing for any uploaded image. You can host it on AWS, Azure, wherever you want. Enjoy. And let me use it. That's it. You'll also get a stats table, so that it's good to download those aspects. Let me see first of all how it is looking like an app. So, okay. What we call it? Album. And let me store it in the downloads. But it will ask for all those package installations, which I would need time to do that. L2.py. No package form. Yeah. Open CV2. Let me start. I'll share this notebook also with you. CV2 open CV. What version is what? It's, let me check. OpenCV-Python. What else? Then I need other library also. VIL also. Let me check. Okay. Mm, which library now? SkyImage. Yeah. Scikit-learn image. Okay. Wow.
Scikit-image.
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 Let
Pip
me-
install scikit-image.
Where is my
SCIKIT.
scikit-? But then this need to change, right?
That will automatic.
No, that SK image.
I think it will include in that. So for SK image itself, we need to install this. Why is it still showing that?
You
It's still not resolving.
lvmin dot.
Keyword.
I doubt, but that SK image direct function. I mean that package column is there. Let's see.
Is it working?
No, that's this
Running.
guy is running. It's a cumbersome thing which we have done, but let's see if it is working. Then it's good to go. At one go, we are completing all the tasks, right?
I think it's
An
taking.
application at the same time we are having those functions ready.
What is the input we given for the chat GPT?
One liner, right? I need all those functions based library. That's it. I mean that app. Let's see. Wow.
Scary.
This is awesome. This is good, guy.
Yeah, good for testing.
Awesome. So let me check salt and pepper amount. Let me increase what? Which can directly give us some. Okay, Gaussian blur can implement. Yeah, you see that, right? This has blurred like it. And you can select all such. Do we have sharing? No, sharing is not designed. RGB shift. Red, green, blue shifting has happened, right? So it's that color is, and all these things need to be changed, right? What else to see? This is equalizing silver mention, right? Let's use that. Very deadly. I think this parameter clahe we got by default imported. It missed our favorite sharing, right? Okay, guys. So I'm sharing this. You can try and you can play with this as per your choice. So sharing that where this is py file, right? So you'll be able to get that. Where are we?
Yeah, PY file, we need to get the location of it.
We can't attach, right?
Oh, can't we attach in this?
Yeah,
I think
yeah.
I think it can be shared.
Just check. So brand it in some different package, scale it up, and see that becomes your app. In the end, we have attached the stat source, right? We can implement multiple functions and see those results. Let me add all my multiple sets.
Ravi, also could you please copy paste your chat GPT I mean
Oh,
prompt
sure.
given?
Why not? Why not? Yeah. See this, right?
Yeah, that's nice.
Let's see if it is downloading. Yes, it downloads the packaged result also. Yeah, makes sense. So I hope you learned most of the things, right? Now image processing is just at your fingertips. Same you can build an CNN application app and apply on this top of this worker. Like for example, fake image detection, create something on a deep fake site using multimodal package is something AI generated. Check that. If you can do that, you are safeguarding most of the people, their public interest, private interest. What you said, Selva? What you said?
The chat GPT prompt, what you make to write for the code, right? That part. Yeah. I mean, the prompt, I mean, because the prompt which just wrote, right, all the code. That's what I'm very
Yeah.
much in.
Let me just take that piece only because it's big.
Okay, okay. Yeah, yeah. And now, I mean, this demo really demonstrates in terms of CNN is not such a very tough animal. Earlier, I was think that I mean, coming to the vision is very complex or something. But yeah, few of the fundamentals, how we are playing around, manipulating the image to fit into, validating. I mean, the required image is, to simulate as similar to what they I mean,
Hmm.
validation purpose and all, all those things are, which this one clearly gives a hands-on nut. Yeah, thank you.
Let me just correct this.
Basically, we have one image, dog image is uploaded, and along with this, give me a
Yeah,
stream.
I'll upload that. Yeah.
That's it. Okay.
Where is that data set? So this dog is lucky.
Same dog.
Yeah, so you can use him. And what I need is I need to give this URL, right? So where you find these functions. What I said to it is in previous prompt is I copied this. Maybe because you will get it directly. Oh, it's only 1,000 allowed. I have to delete. So don't use this. What you can do is I'm sharing that link. Maybe you can log
Yeah,
in.
in the chat GPT, I can access that same link as well, otherwise.
Yeah. All right. So I think we're good today. I mean, instead of starting a new thing, I think what we can do is we should start fresh next week. CNN part 2. Meanwhile, you can practice this. 15 minutes you have. So what you can do is you can try to run this app. If any challenge, let me know.
Just wanted to check, is the drive link collab files
Yeah.
accessible
So,
for
do we have
everyone?
Adra? Adra here, please.
I could not
If
access.
I give it from my side, then it will be again. I mean, they will not be able to upload on that link because that's not their official one. So that's why when Selva mentioned, I mailed it to them. Let me have a strong follow up, and then I'll update you.
Okay.
Maybe we can stay here and let me call her, and then we go. Remaining time, you can build the application with respect to what I mentioned. So just see if you are facing any challenge there. Right. Okay, let me call. Yeah, guys, I told her she is going to upload. And meanwhile, somebody applied this? I mean, experimented. Anybody implemented Streamlit?
No, Ravi, I did not. I need.
Oh,
setup.
No worries. So I told her the list, so she'll just uploading. Don't worry.
Yeah, Ravi, I think
yeah.
good with that. I mean, I can run it definitely. If needed, anything will.
Sure,
I
sure.
think
Do
it'll
let
be
me.
good.
Or you can mail
Yeah,
it. To me. That's
yeah, that's it.
okay.
I'm good from my side. Yeah, we'll catch up on next week, sir. Yeah,
Yeah, yeah. Thank you so much. Thanks, team. Miss
thank
you
you.
this week, but yeah, let's connect again.
We'll check this out. I need to make
Sure,
some
sure.
ground setup. We'll check this
Oh,
out.
okay. Got it.
Thank you. Bye.
Perfect, team. Bye.
Happy weekend, Ravi.
Yeah, same to you. Thanks. Happy Deepavali as well to everyone. Bye. Sasi didn't participate today, right? Sasi, all good?
Yes, Ravi.
Yeah, today we missed your participation. No worries. Okay. then.
Thank
Thanks.
you.
Yeah, take care. Bye.
Solunga Suresh.